I need to have that fun part in the beginning. Anestis, welcome back again.
I'm glad to see you again, and I'm very pleasured and as usually honored by this invitation and the chance to discuss real, hands-on things on machine learning and issues, and focus on special parts of this whole workflow that sometimes looks so complicated. So it's good to have a chance to demystify and to explain things more.
That
Thank
sounds
you, Stefan.
Anestis, but you have been traveling a little bit last time, and I heard you're working and running a company which is called DeepLearning.AI, right? And you have been awarded a prize recently. Tell us a little bit about that. What happened?
About my last visit? About?
No, your prize you got with Meduit.
Yes, of course. Okay, thanks. Thanks, Stefan, for mentioning. Okay, we had this great pleasure to have this first place winning a prize from Pfizer, a prize on human-centric and patient-centric innovation, a contest that was organized here in Greece through Elevate Greece, a state innovation management organization. And we won the first place with
Awesome.
quite novel, and I think at least we love this idea. Pfizer did too, on summarizing and producing layman terms summaries of clinical trial results. A very hot application with the main goal, to make clinical trial results and all these medical documents more accessible to people. That's the vicious cycle of misinformation. If you don't have access to trusted sources just because their terminology is difficult, just because they are not accessible because we need some medical or pharmaceutical knowledge, you turn to sources that are not that trusted. This is a good chance for science to fight back, simplify its texts, and make them available to all people. That was the winning proposal, and thanks for mentioning this.
Awesome. I think the Prime Minister was even attending the show, right?
The CEO of Pfizer and our Prime Minister was there in the awarding ceremony. And yes, it was, wow, what a moment for DeepLearning.AI.
Yeah, I'm proud to know you. So it's good to have you here. Thanks again for joining us, and welcome everybody who has just joined us today. We have a quite interesting guest and quite interesting session. So it's the second time actually Anestis joins us, this time for a different reason. We already gave an outlook of what we are looking at today. So it's really about machine learning and the Sprint Hero. So it's Sprint Zero and Sprint Hero. What does it mean? Can you tell us?
Yes. Well, Sprint Zero is a terminology often used in agile frameworks. A sprint is a unit of work, usually considered a 2-week effort of a team, a 2-week period of trying towards some specific goals, stories, or any way called, in the agile methodology. So Sprint Zero has a special place because it's the first and the defining sprint on the goals of the project. So it's this moment, this important moment this important time that you have, you can actually plan resources, set goals, greater goals, strategic goals, and define your problem. So it's not everything agile. There must be some period in the beginning that you set the principles, the most important defining aspects of project. And as we will discuss later, this has actual value for how the project will eventually turn and work, and how and whether this will succeed as a project. Sprint Zero is defining.
Interesting. So Sprint Zero, I'm thinking about relationships between people. So it's like the first time we meet, and can we fail so hardly in the beginning, but everything is just doomed? Or is there some way, if the start is not that good, we can correct it afterwards?
That's the moment also of the second part of the phrase, because of the title we gave, because Sprint Zero can be a hero and save things that we cannot immediately see in the beginning of a project, and they will be visible far to the end or while the project evolves. And if you really define this on the beginning, you will win a lot of time. You will gain a lot of time on the rest of the project. So the Sprint Zero can be a hero, saving time, and yes, else we turn to the team for heroes, and that's not nice. The team will have to be the hero to
and saving everything yourself and rescue team, rescue team. Okay, thanks again for all the people who have joined. Just an organizational issue, because you probably have been there already, but this kind of platform allows you to raise questions throughout the talk today. So if you look at the navigation bar at the bottom or the top of your screen, I have no idea what it is on your screen. Can you check? There's a Q&A part where you can actually ask questions. If you have questions, please feel free to do that. We welcome any kind of question, and there's no silly question, as you know. We love questions. And this is so really, I'm happy to have you here. And I mean, it's now time for you to help us, but Sprint Zero will become a hero from the beginning. Help us to save the time, okay?
Yes, I'm happy too, as I said, and I'm always glad because you have, Stefan, this way to relax your guests and to prepare them for any talk and any discussion. I think it's always a pleasure to talk for AI Suisse and your people here and this lovely audience.
Thank you.
Always happy. So let me begin by sharing the screen. And of course, Stefan, you can give me a warning if time somehow, flies and I lose this sense of time. And I want to give, before I begin, two or three thoughts, two or three things I want to say. First, if this can work and we can try, I would love it to be an interactive session. So you can raise hands, make questions, and there are several topics discussed. So some of these are more interesting for some, and some others for some others. So please feel free, all of you, to make any interruption, ask something, or we may also have some Q&A short in the end for anything left. You can write down or note the number of the slide that we will be discussing and have that as a reference. Next, there will be a lot of material. Some I have references and sources in the end of the presentation. So some of this material, tables or figures that I used from other sources are all mentioned and referenced in the end of the presentation. And we will also have these slides available to you after the presentation because they will actually be useful. That's good and bad in the same way, because I warned that there will be lots of texts because this topic involves some checklists, things and questions that you need to consider. So it will be kind of heavy on text, but as I said, it's also a good chance, for discussion and working and thinking on these slides.
But I mean, checklists are perfect because this is helpful. Yes, it's just like concrete things we can do. But that's perfect.
We're usually in this era of visual communication, mostly we are emphasizing, but we may also have the chance to draw these concepts together and create even charts or ways to connect them. I will be glad if I listen such ideas. So, defining machine learning projects, let's begin with the most abstract view, which has to do with our goals, our end goals. We need to develop some machine learning project. There must be some reason at organizational level, at personal level, whatever the reason is, and especially because we are now focusing on business cases mostly, There are 4 broad categories of things we can do, things that can be the strategic goal of a machine learning application. These 2 dimensions is the dimension of business processes versus product, and the other dimension is innovation versus optimization. So we have all 4 combinations of things. We may want to innovate for our product. Another word for this would be disruption. We are disrupting a market with some new feature in our product. This is in the upper right corner. But another very standard case on the other extreme is that we have an internal business process. Let's give an example. We have some compliance team in our business, and we have some fraud cases, or we have running an anti-money laundering, we have transactions, and we want to have an anti-money laundering system put in place. That's a business process that we are supporting. It's not some customer-facing application. It's not our product. It's not our core business. It's our internal business process. And we may just want to optimize it, improve it. It's not that we are going to disrupt or innovate. So the first thing that we need to make clear is these dimensions that will set our goals. Will be a first defining step anyway. We can be more specific than that. We should. So what we say is that every company, I would say organization, I would say small teams, because there may be students also today watching us, and they can think of teams of people with other colleagues or other students that want to build a project. So every team may have this machine learning opportunity, but not every problem can be used by machine learning. Now let's go to an extremely different view of the things. The one was a business and strategic view of what on a higher level we want to do. This other end of the spectrum is a clearly systems view, still abstract view. Yes.
Sorry for interrupting you in the beginning, Glenn. So the first, when you define the business part of it, are you really using that kind of coordination system? So to say, okay, this project is about this section, and we use that and define the goals. So really use that?
Yes, you would use it in a very first step in terms of on which of these squares or sectors in this Cartesian would you find more value for your business. So it's a first direction to understand that, look, my product needs some improvement, but has found its market reach, and I don't need to disrupt or innovate. It's about estimating your immediate priorities, and you attach this. It's a good chance, your question, to see exactly just a little bit later how you can attach things to this and understand, make this a little bit more practical.
Okay, got it.
Now, in this second and very different view, you know, we all have been reading, you know, online and other literature discussing about this new software 2.0 paradigm of machine learning. This is the part on the left. We say that machine learning has changed the traditional, and my cursor probably is not viewable. Can you see my cursor? You can. That's great. This is the traditional, this is what we have been discussing the last year to the very recent past about the machine learning paradigm. On the right, we can see the standard software paradigm that we give data, we give some logic, and we get some desired behavior. But on the left, we have the machine learning paradigm that we still feed some data, but we also feed, you see how things change, we feed the desired behavior, because a machine learning system learns from behavior examples. So we give some examples of behavior, and the machine learning system, what we call here software 2.0, learns. What I want to show in this slide is that what we are going to define today is the combination of the two paradigms. And this is how these two paradigms are combined. So a machine learning system is not standalone. there is still software around it. And so when we are carefully designing for a solution, we should take an approach, a software systems approach, and understand that this is not just an experiment that we are running and we want to have some good metrics. This should be delivering actual results to people. There is always software. The system gets so even more complicated because it's this combination that we try to define. It's not only the machine learning part. Now, about the nature of a machine learning project. The previous view was the system view, the project view. You have been seeing, and there are many older frameworks on machine learning project, CRISP-DM, and many others you may know. What I personally like and kind of have picked is this machine learning development life cycle that shows the strongly iterative nature of machine learning project. This is important to know before you define, before you really care on any role you have. You may have the business role, a business stakeholder role in this project. You may have a technical role. Any role you would have, you should have an understanding of how this will work. So this project will be iterative. There will be inner cycles. There will be a greater cycle outside here that passes through defining the task, which is what we are currently doing. We will begin doing. And then we will collect data, we will test, deploy, monitor. But in some point of the cycle, here somewhere around testing, things will go back and may need to go back multiple times. This highly iterative nature of machine learning is also the greatest source of risk on any machine learning project. This needs experience, definitely some senior part on the team, understanding the risk and adopting a development workflow that can sustain this risk. Example, the agile methodologies, for example, designed by default to have this shift of requirements, of environment. They fit naturally to the risk and to the iterative flow of machine learning. So to move on, performance-driven, feedback-driven, a standard software system is not always performance-driven. Machine learning is strongly performance-driven. Performance is defined by metrics. We will discuss this. And it is data-driven too. So if we make some web app, it's not data-driven. It may be designed for some data, but it's not using this data to do, any task that we may think of. These are distinct features of machine learning. Now, a more detailed view. And this detailed view will be the skeleton, the outline for the rest of the talk. So as we can see, it's this iterative nature from data collection to data modeling and deployment. Problem definition, the data and evaluation needed, many more things to consider than standard software development. But we expect some gains from this. Using and adopting some machine learning technology, usually there is an ambition for exponential returns. So there is a reason to actually, have all these considerations. Features, the modeling part, the experiments. I assume that most of you have some basic understanding of machine learning, so I don't go into details for any of these. But let me give you a thought on how we will continue from here. Yeah, yes, Stefan. Yes, I can't hear you.
No, better.
Perfect.
If you're mute, no chance to talk, right? So thanks again, because I prepared a poll and which helps a little bit to be focused on what matters. I'm going to ask, and I will start it right now because I think it's a good time to do that. If you can have a quick look at what kind of profession you are. And
yes. Nice.
That would be very helpful. And it helps Anestis and me to focus on the things that matter for you and you want to save time.
Yes, that always helps. Yes, we missed that. It's a very nice thing that you're doing. And I will continue when we will finish.
You can continue, yes, absolutely. Thank you.
Okay. Okay. Yes, should I continue?
Yeah, you can.
Great. Now, why are we discussing about all this since we are focusing on defining a project? So these are steps that are ahead of it. Evaluation, features, yes. All these steps, all the steps of the life cycle should be discussed upon project definition. They may be actually decision points. They may affect the decision on which project we'll take. So if we don't have a clear evaluation strategy for one project and we have a clear evaluation strategy for another, okay, I can see the results. Good, nice.
Very interesting because as we can see, so the data scientists are also there, and looks like both you guys might move into a more product oriented role. We are project managers, which is beautiful. Ours, welcome.
I have a good list for that for the product manager view later on. That will be useful, and all this will also be useful offline to have this material. Now I will just briefly present them, but it will be good to keep that as some material. Now, so all these steps are important to be discussed and defined in an agile way. It's not that we will have some final definition of things, but we need a first, we need to have a first set and the first decision on each one of them. So for example, evaluation. Evaluation will be done after the first model deployment and probably, of course, on every try and every training that we will do to the model. But you need to have some evaluation strategy before even you begin any sprint, because this will align, should align also with your business goals and your business metrics. Okay. And it can be a decision, an important decision aspect on which project you will take. If you don't have a way to measure your success in one project, but you do have in another, you will pick that project. Now, strategy-driven machine learning. Let's begin with all those that we usually call business owners and the people that really, set the strategic goals, and they may actually manage the system even in an operational level. And everything should begin with them outlining strategic goals for the business, for its main specific actions. This example of an e-shop, an e-commerce store, may be the main activity of a business. And always what the business owners identify are at an abstract level events like this: low sales this quarter. And they need to set some business ideas on how this will change. Now, this example is indicative, but see, it's far away from any kind of machine learning definition yet. It's just identifying a business problem. The business representative has a checklist, really, even an abstract one. You can think that these are the important parts. They may assume solutions and estimate impact from historical data because they may have some similar solutions deployed. You can see that mentioned here, BI help. This is the part where business intelligence, BI team, will come to help and provide some metrics, analytics on different solutions in the past, or what are the pain points in the current solutions. This will drive the discussion even before we talk about technology, machine learning, or anything else. Now, many ideas will come up, and you need to prioritize these ideas. Now, this is another example, another useful matrix that can help you. This matrix, and many of you may be familiar with it, it's quite practical if you assign projects on it, candidate projects. On the upper right corner, we have projects that can have high return. We estimate a great return on investment. They have high value for us. They are very attractive for our customers. And they have high complexity. Down on the right bottom corner, we have what we call low-hanging fruits. That's always a good start for an organization, wanting to deploy AI for the first time. You would not begin with a complex project. You have to build your team, test how things, and scale gradually. Scale also on what problems you seek. Low priority functions, we understand that this is usually a trap. This is a very nice trap that I had in my experience, several business clients. Many times they will go to the lowest left part of this. So low complexity, it seems easy to them, and not much value there for them, but they just want to try things. And of course, what you should definitely avoid, at least at start, is having any high impact project. Okay, it's the same. It's the reverse. I actually read them in reverse. So we are striving for a project with high impact and high visibility. Before we move on, just these two quick tips. My best idea for this is what I call low-hanging fruit. So anywhere that cheap prediction data are readily available, these kind of things are good projects. Rule-based, any rule-based solution that you are currently having or deployed, yes, can be replaced. And it's always a good indication that the business part is mature. Since there are rules in place already, that means that the business part is well defined, so it's also a good opportunity for machine learning.
Since we have some psychological moments, if you go back to the previous slide for a second.
Yes,
I just would like to understand a little bit your experience. So we're from the tech side, right? So usually I'm from the tech side as well, and we need to talk to the business people. What is your experience? Because what I learned is sometimes hard to get the message across, but these are kind of projects like machine learning projects where I'm not 100% sure about the outcome of it. You have some risks you have to address, as you mentioned. So the low priority functions, the low hanging fruits, this is something you actually would say, do something like that in the beginning so the business can gain trust in what you're doing before you start to get deeper into more scary projects?
Yes, of course. Now it's very good because you also mentioned trust. I will mention it also later on. Building trust to the technology and to the team. Yes, that's what such low-hanging fruits can really help. But to be honest, you can really build trust also even on more complex projects, even if this is the first time, because trust is not actually an outcome of success or failure. It's an outcome of visibility and understanding and ownership. So if you have your business stakeholders close to the project and its workings, and it's having an understanding, sharing a story with you. But that was a very nice thing that you put there. I will mention it also later. This thing, it's not like the first square thing that also can have a practical value, but in this case, it's still an abstract thing. It's not that you can directly use it. If you have multiple candidate ideas, yes, you could attach them in this matrix-like square and help you decide. The important takeaway for you are the axes, the defining axis that must be your consideration axis. Okay, attractiveness and feasibility, value versus difficulty, very primitive, classic.
That's pretty important. So that would be the last questions I have regarding from the beginning what you have been telling us as a story now. If you have projects with where the scope is not really really fully clear, because you know the scope is clear, but maybe not the steps to get there. So it's you're tapping into new knowledge areas, and it's just like, okay, we have to test a lot of things, do a lot of research. How do you actually plan something like that? And you using that kind of methodology approach, how can you deal with that?
Yes, we will come to this a little bit later in the next slide, that we will have these checklists and questions, but always think that on this very classic and very understood question, and the risk, will this succeed? Will the model, the training work? Will I have a model in the end, system working? This is why we answer to this, take an agile methodology, that it doesn't only redefine technology every cycle, it may also redefine the business goal if things don't work. So this is important for us to understand. This is why we should be very close to the business team and have a shared ownership. So it's not only a matter of fast technologies not failing and not being able to provide results. We share the responsibility, even defining the problem. That's the greatest responsibility, defining it, greater than actually trying to solve it. And so I'm trying to get in quotation, the guilt out of the development team, or at least share it with the business part, but it's a big thing. So 2 examples for candidate projects in 2 different businesses, reducing the time. This has to do with image recognition and outputting some image caption automatically for some post. You can see that in bold the keywords that you are trying to identify in the wordings of a business stakeholder. Reduce the time. Okay, we have a requirement here. We can see image caption, understanding the object that the whole project will revolve around. The same thing also in the example 2, automate generation of stock recommendations. So we have to recommend keyword, and we have to predict what are the data recorded here. So these are short descriptions. Defining questions, a checklist to keep with you for general projects. We will come also to a more detailed one, but some of them are very fresh. I mean, it's good to doubt everything in a process. So even we should even think if this problem really requires a solution. We are talking about problem. It may not be a problem, maybe some proposed innovation. Okay, and sometimes interchangeably we use problem or any other. The nature of the problem, if the problem requires a solution. Now take a look at this. What aspect of the problem? So the machine learning part is not always the greater process or the greater problem. It's an aspect of that we are dealing with. All these help us increase the dimensions on our mindset and on our approach to be more open. Very important. How is the solution intended to be interacted with? Now, let me give you just for a second something from my experience. When we are working on training models and we are on our screen coding, trying and experimenting and running, we are very isolated. We may build some silo that is a developer silo, that we actually forget the way that the system will be used. That has to do not only with user interactions, but with readiness of data. Data are available just when we are, training and testing, but the very same data may not be in our production case. So we need to think of the interaction of the user, thinking the system live, only live. We have to think how it will be. But this is a project manager's view. Another checklist. I had to give, two versions, a more detailed one, that this one has in bold other more strict definitions and requirements, like there will be timelines. Another one, very simply put here, dollar value, but it can be whatever the expected return of that has to be estimated. A very important second one, how could the problem be solved manually? We will come to this later on again. In another slide I have made here, that is about faking the machine learning part. That you begin by thinking if just a human would serve these results, and even testing such results that a human would produce, testing them to the end user. So a product manager has also to think of use cases. Depending on the organization level, may even have to write them. It's not a bureaucracy thing. It's really identifying things and putting them to paper. Documentation starts from here, starts from this part. More considerations. We have tried to frame a problem. There were two examples. As I said, we can and we will discuss about faking, in quotation, the solution and thinking of other workarounds. The important thing, and the last two bullets, are those that we will discuss more in the rest of the presentation. In the rest of the presentation, we'll discuss how we determine the type of machine learning and how we define success. So, this is my personal methodology, a very simple methodology. The 5 machine learning verbs. You discuss with someone, a business owner, a business stakeholder, they express some first version of their problem or idea, and you seek for these 5 verbs. These verbs can be a first translation to the technical team. So if you want to check for feasibility of the task, in the first initial discussions, you get requirements, discuss feasibility, and back. Okay. We assume that a project has already been prioritized from the previous slides we discussed through the value and all that. And this project, now we seek for these words. In machine learning, we can do any of these 5 things, no more, no less. We can control. This directs you to, for example, reinforcement learning methodologies. We can cluster, that's clustering. Some business users, be careful, call it segmentation or something similar. We can classify objects, we know that, but we must keep the verb. We may predict or rank. In the ranking case, you can think of recommendation systems. Recommendation systems is a good approximation. Now, 2 examples, excuse me, 2 bullets. We have an insurance company, receives claims. It must be, this, I'm avoiding the word right now, the hot word. It has to determine whether there is fault or not. The number of claims is big. This is a classic business reason to scale its processes through machine learning. That's a very clear indicator. There is no disruption here in our first square matrix. This is optimization. Optimization is also about scaling, being able to scale. This should be transformed like that. We are this car insurance and we want to classify incoming car insurance claims into at fault or not at fault. Now, a machine learning project may have 5 or 6 or more instances of this. This would be a very short and very specific, unrealistically good project case that can be so well defined from the beginning. but you decompose all these requirements into such little short and clear phrases. Now, these phrases should also have some indication on how things will be measured. We will come again into that, how we will measure success. But this is something you can begin with. Now, I will go back here, and we will begin quickly to have a view on each one of these. So, what things you need to define at sprint 0 for data? What things you need to define at sprint 0 for evaluation, etc. So let's go to data. We first begin with the data collection strategy, especially for organizations now beginning with machine learning, either having a team or outsourcing this. This is their work. Data, as we know, is the ultimate asset. These are taken from the relevant literature. These 3 points, it's not something I came up from my mind, and they are really good because they mean a lot. Democratizing means that everyone in the organization has some level of access in this data and an understanding. It's not isolated. There is documentation for this data. This is important to be able to discuss with the business and the owners about this data and having responsible contact points on them. And an important aspect is data that have worked again. That's the ideal, that this data have been used again. It's not just an output or a log from some process. That's the ideal. If we can have data that have been used again, and there may be some cleaning process of them already in place. That's a quick win to begin quickly with a project. External data opportunities, I don't need to read this all to you. These are important. And this is also a source of innovation for any idea. You may have, all of you, some idea for your own machine learning project that will be based on data from your organization, the one you link with external data. A great opportunity to bring some innovative or augment some information and enrich your information. An important checklist also to keep. So how do you plan for data? I want mostly to mention, especially in our today's understanding, all the privacy and security parts, having permission, collecting, using data. I should strongly emphasize these questions. On the quality concerns, and usually you won't see this in the literature, but I also mentioned the bias part. So let me give you an example. If you get interaction data from a local region, you don't probably have represented people originated from other places, other locations that have their own needs, that they have their own way of expressing. And if the system is exposed then for use to people worldwide, there may be a significant source of error. And so we need to focus on bias where our data are given. This has to do also with the old dark art of sampling. So we need to have all these things. It's a good place to be thought in the beginning of a project or of projects. Just for our understanding, there are types of data. You can ask me anything on that. I will give you some examples on labeling now. I have an example right after this, but we first need to understand. So programming machine learning, I call it, okay? If we can give labels, so examples of behavior, of the behavior we really want from the system. In a supervised case, okay. Labeling is also a very important consideration on the project that we will choose to work on and the project that we will define. whatever we do, there is a lot of risk on that, especially if the labels come from people and are not events. You can think of an IoT setting. You may have labels from produced from events. A person entered a place or a person left a place. That's an objective label. That's a real source of truth. But you may have a project that the labels come from people. And if the people change, if their methodology changes, so choosing a project, this is very important. It shouldn't be considered, given. We should all think of this. Now, a very good solution is to document. If you need to take such a project with human labeling and all that, you need to document this. There are solutions. Nowadays, if you can't have these labels, I mentioned 3. Transfer learning means that you can boot your system, your idea with a model out there. Nowadays, there are lots of them. You can look at Kaggle, the competition ML pioneering site. You can boot your model from a given model, a given open, and then you can tune with less data. And these special labels you have, but there may not be much, but they can help you tune your model. You have the classic active learning approaches, using labels, training with them, and using that model to get more labels, and sometimes propagate error this way. But anyway, another approach. And a very nice approach, I personally haven't used it yet on any work case that has come to, but it's always a smart thing to do, is what we are calling quick labels. Get some, consider as labels some metadata. You have some object that you care of, which, for example, maybe some Instagram post, and you want to parse and crawl through some internet. You have the tags. You can consider things like that as labels, if they are close to the metric and the thing you are interested in. Last thing before we move to an example, of course, we usually say the more data, the better. We also discuss this about labeled data. And this is something that from all our experience is valid. We have some diminishing returns after some amount of data. And that's the ceiling of your machine learning methodology or approach. It's what you can actually achieve with the method you pick. So more is better, but this correlation doesn't work all over. Now, let's see an example. Let's see quickly an example. And if we have, like 10 minutes, 15 minutes, we may be able to see all the presentation. Now, this is nice. I want you to see just a short example of things you need to consider as a risk source before you begin the project. You make your timelines, you make your estimations, but if you haven't discussed with your tech team thoroughly, and especially with your data engineer, you may not see this source of risk. What we have here, we have transactions from 2 users, user 13 and user 14, and they do some actions through time, B, C, D, E, F, etc. And yes, you have some business domain expert that labeled these users. This is a non-fraudster. It's a fraud detection thing. And this is a fraudster. These are the kind of things, these are the kind of cases that you should be careful, because this second case of this user, he's not a fraudster per se because of all of his transactions. But the label is so abstract and coarse, and it goes and it's attached to the whole transaction history of the user, because at business level, this user, okay, now is considered a fraudster. But for you, the machine learning engineer, the data scientist, you wanted to discover a pattern, a sub-pattern in his transaction history. And the label for you should actually be in just that part of the history. Because, for example, you can see that there are many similarities between the two users. You can see EFFL is also on a fraudster and also in a non-fraudster case. But now they are piled together. That was the pattern that was really different. These 4 A's in the fraudster, but the label is not attached to these 4 A's. The label is attached to the whole of the transaction. So these are just a tiny little example of things that you need to consider that can make things slower while the project goes, because now the team will have to think of a way to introduce windows in the transaction history and attaching the label to these windows and not attaching the label to the whole of the history, or may try to experiment like that, but introduce some noise. Team. We talked about the data. Now let's talk about the team. We are at the defining stage of a project. We need to set up our team. And I gave also in our discussion with Stefan's nice question just before some considerations that have to do with the culture. So culture is not just a buzzword, it's real. It's a common understanding of things and goals and the feeling. You work with these people every day and you want to share some goal and have and enjoy wins together. And to do that with your boss too. So the culture of experimentation, I say here, that's a code, that's my code I like to say, I hope it's nice, that you cannot do machine learning in a non-learning organization. So learning means trying, failing, trying other options. This is all about machine learning. We saw all that cycles, iterating. It's important to have what I call the buy-in from the executives. We have to understand that machine learning, and I have been discussing this with many, CTOs and people and executives that expect results and usually expect them immediately, that the evolution line of a project in machine learning is not linear as the classic software development paradigm, that every week adds a specific part of the value on it. In machine learning, you may spend longer without any, value as we can estimate it, and have an immediate or sudden increase on value and what is produced close to the end of the project, because there is a lot of experimenting, may need not be. This is important. You need a culture that understands that it's not about being greedy, expecting immediate returns. It's investing. If you don't have this, there will be a lot of pressure on the team, mediocre results midway. Last mention on this, skill gaps, and for that it will help this quick little view. A happy machine learning team, the one you need to set up, the minimum team you need to set up to begin. You have a business stakeholder, you may be the business stakeholder, knowing and understanding the problem, having picked the problem along with the team as we discussed, this product owner, a role that we were also calling in the past as business analyst, is also a translator sometimes of business terminology and requirements to actual technical terminology. In our current agile schemes, it's not a manager. The team manages the result, the team manages itself. This is important to say. You expect that the developer should be in the team because, as we said, we build systems. And now, interchangeably, there must be a data engineer or a machine learning engineer So it's not very accurate in this scheme. It depends on how heavy is the project, how heavy is the project on the production side or on the data pre-processing side. So getting into production is difficult because you have a real-time system that is serving millions of users real-time. So you are very heavy on the production side. It's not some back-end job running and a report going out every month. The production side would be thinner. The machine learning engineers' usual work that has to do also with the deploy. Or if you have a very intensive on the data part of things project, and the data engineer, a clear data engineer role would be useful. Lots of data pre-processing, complex databases, data lakes, unstructured data, etc. Now, dear Stefan, how much time do we have yet? I think we won't need, I can keep
10 minutes.
Yes? Okay, good, thanks. Thanks. So I'll try to go some things quickly to leave room for discussion, and I will just tease you with headlines. So things that you may be interested to discuss. Now on project requirements, we should open our mind also on that. There may be functional or non-functional requirements, as we have been talking about them in the past. So I'm sorry for those that don't have the technology background and all that. I mentioned some things, functional requirements, etc. We may want to optimize for the accuracy. We may want to optimize for speed. I can give you a nice example on that. It's not just just a list that we can say, okay, let's choose. How do you choose, between these examples? You can have as a client possible, you may be working on a team that is working on trading, stock trading. Okay, especially if they're working on algorithmic trading or high frequency trading. For them, accuracy or any kind of performance metric won't be important as much as latency and speed and being able to quickly process the history that you currently have. You're working in a millisecond level. So it's not given that performance is always the thing. It's the ratio of performance you can give for a given latency or for a given, so you cannot have some very complex model, or you may need to develop it on a lower level language, C++ or something like that. Always mentioning interpretability or explainability, a very given requirement for any model, especially if it has some social impact or has some. So the future models, robots, AI should be held accountable for their actions. They should be able to explain how their actions were produced. Please, all of you, especially our data science friends in the audience, they have already, in the past 3 years, this has been very emphasized. You should really put in your portfolio and your skill sets some explainability techniques, always along your machine learning toolbox. Now,
so yeah. Doing that, right? Explainable AI. So in the models or in the projects you're running, actually go into inside and try to give more understanding how the model itself works to be more transparent for the business owners.
Yes. Yes, it can be also, yes, that's really also for the business owners, also for the model to get this green flag to go in production and actually serve customers, because it's a way for the model to be trusted and the system to be trusted. You don't want a good performer that you don't trust as a model, even for that single case that can bring legal costs and can bring other cases. So that's important, and it also defines the methods that you will choose, and etc. Yes, explainability. Now, on the feasibility side, a checklist that it's good to check after we finish. So this is what you discuss as a product manager or a product owner with the tech team to be able to understand the cost. If you understand the cost, you attach this cost to the square matrix. You have the attractiveness given from the business side, and you have the feasibility and the cost actually given by the technical side. These two sources give you this, we're going back to referring to the matrix of decision. Some more thoughts on Agile, and I want to check if I will, okay, I want to tell you this one before we are done. Now, important thing before you begin a project is to be able to define when something is done. This is inspired by Agile methodologies, but it is very important in machine learning, and especially it relates with the evaluation metrics, things that we will check in a second. Another important inspiration from Agile is it's not about results, as some friends asked before from the audience, but it's on how much time you can give some results. Yes.
Questions here again regarding the roles, because it's getting a product in the hands of your users. From traditional software development and from interface development, we know we have people in the role of human interface design, human interaction design, so interaction, less the design part in the sense of drawing some things, right? But designing the interaction and the usage and the experience, basically. In looking at the models and working with users in the end, and you showed the roles you had in the plan, like more of a tech stuff and project management and so on. There's not a defined role for someone who's doing the experience design. So experience with the data itself, is it not necessary for machine learning, or do you think is it a skill set someone has to have?
Very nice. Okay, so if I understand it correctly, the UX part of machine learning, why is there is not a role for user experience?
Go to a website or something like that to be clear here, because this is a model, still a model, but you get data and you get it in some ways, and so this is kind of if you show that to someone who has to use it in the end, there needs to be some thoughts of, yes, experience design. So how does that work for a user? Who has the skill set?
That's the best. That's the best. Okay, hope I helped the focus again. That's. I hope it is covered by this one, which is my view and a tip for actual hands-on projects from my experience. And as you can see, I have this bullet here on prototyping, also the user experience part. And I give some suggestions for Figma if you're light on data and it's just an experience, or if you want to be closer to the data and the processes, you can use something like Plotly does. It's very good, especially for the beginning of the project. I agree that to have a very first quick mock-up, and maybe even in the first sprint, not sprint 0, on sprint 1, it's good to, what I say, complete the cycle, create a whole experience. That's what we say here, iterative but complete solutions. And for this reason, you need to fake the machine learning part, isolate it, so that you can isolate also its returns, its evaluation, have it integrated, and be able to modularize it, and have that part of the team work on a modularized, more stable environment. So yes, prototyping, iterating, it can even be done with what I say manual human effort, especially in sprint 0. In sprint 0, a product owner could try some human results on the end user and see if these results are interpreted as he would expect So he can also, these interviews are very useful because you see that how the end user evaluates the result. Is my image still blurred? Okay, let me check that. Is it better now? Okay, good. We can discuss on that. Please tell me so. We have to, these are heavy on text, but just I want to give one line per each, and we are very close to the end. It's just two slides to the end. So we need to set up, this has to do with our understanding of the solutions, and we need to set up the evaluation. On Sprint Zero, you should have it on a documentation. Make a Google Doc or something like that, share it with the business stakeholders and the tech team, and start recording this from literature. Estimate the human level performance, if there can be some human level performance of that. Performance from Kaggle competitions, other models on relevant tasks, how this data were different with the data we have now. Because if the data are different, the performance, of course, will be different too. Searching the literature, especially for those of you who seek innovation. You seek innovation. Innovation path is through journals and papers. You need to search papers and see other solutions to what they have tried. It doesn't matter that this is not, this has never been to production. That's your innovation opportunity. Taking such a solution and adopting it. Always a view on the evaluation metrics. This is not a machine learning 101. This is important for being aligned to the business metrics. For example, you are predicting, we had a project, we have been working on natural gas consumption prediction. Is my image stuck? You can see me, okay.
Yeah, I can see.
We could forecast. We could forecast and we had quite good scores on our evaluation, especially in an horizon of 3 or 4 days ahead. But what actually mattered for the business was a penalty they would receive for the forecasting error. So for them, the end metric was also calculating that penalty in the equation. If we would win a lot of time if we had fit our system right from the start on this penalty. But we were working for like a month or something since we started development just on the forecasting accuracy and not on the actual end use, because especially on some days, weekends, the penalty was less, we could adapt better on some other days, and we would focus and actually get the business metric down. But we didn't at start. So you don't just put to refine the model, because what we have done is we evaluated the model, and now we need to refine it. So we don't just tear up and all that. We need error analysis. That means that going on every little line of our data that got the wrong label, that got the wrong classification, and checking why these features, why these descriptions of this line, how this affected our wrong classification. Error analysis means going down, being humble, and going down to data at a low level, not just forcing global results. But just checking and rerunning. You need to go down to a line level to understand and see the similarities. Some clustering techniques will help here to cluster error and be able to see that. So bias variance decomposition, for those of you that don't know, and allow me for those that are not in the business interest, but please, I have to give this, has to do with seeing the difference between your test error, your validation error, your training error, and these differences all suggest different changes in your model. if it's overfit, if it's underfit. By these differences between the error of test, validation, or training, you can see your next step and refine your model. Testing, we are producing systems. This is not the favorite of ML guys topic. We are producing systems. This is also sprint zero. These are really all about defining the project, the testing policy, where they should be written on the first step. These are all the things that you should do. Tell the team, the technical team, the development team, to start at their very first day. We are about to, okay, final thoughts, I'm going there. This is another important thing for the definition part of the project. How I will just focus on the last two ones. Canarying, for those that don't know, is deploying a model. Yes, I can hear you, Stefan. Good. It's a very nice approach. Deploying the model only to a small percentage of your users for customer-facing applications. It's a nice technique and also can work with A/B testing. So depending on the system, you can go safe or not. So the shadow mode is classic, is that we don't trust the system yet. We use it for some real-time data, we get the result, and then at some point we trust it. Canarying is more fresh because you gradually get real data and you can start also from some safe part of your users or some control group. Planning the main, I will skip that for now, and we can conclude with some final thoughts now. The last one was really a final thought. I put it in the presentation some minutes before we begin because I said, oh, we should not miss this. People don't really talk very frequently about business definition depths. They talk about the technical depth. But there is this business definition depth that it's important to take over in this phase on the sprint zero on defining the machine learning project and try to be as specific and certain you can, because the development team, in order to anticipate any vague definition, will have to increase complexity and make a system more generalizable to anticipate the change. More parameters introduced, more flexibility on the user side, unnecessary flexibility in many cases. That will increase maintenance cost, will increase, they can do the other way. They can take a case and develop for that and actually have the development team decide and make the business case more specific, but the risk will be greater if something changes on the business side. And so there is this business definition depth, and we have seen that in real projects too, in fraud detection projects, not giving the time, having some person from a risk team, a business professional, saying that right now I can define this pattern very well. I have these two cases, I don't have the time. This is a lack of commitment and also a buy-in from lack of the buy-in of the executive side. I don't have the time right now. The sprint has already started. The first sprint, the project has started. I don't now have the time to consider these cases. Don't consider them yet or whatever. When the project starts, it's not the development team that starts only. The business owner, the product owner is also working with them.
Definitely, yes.
Thank you very much. These are some of the sources and of course my personal experience all these years on these projects I will share with you. Thank you very much, all of you, for giving this time. Hope kind of help. Any question will be welcome.
So yes, yeah, everyone is just invited to raise your hand, so to say, and put a question in the Q&A section. I will definitely ask you something, but Jano is asking, what is some best practices for a story format in backlogs, acceptance criteria format, etc.?
Yes, I can read it. Hello, Jano.
Do you recommend So you use 3 points hours or whatever.
Yes, what is some best practices for a story format in backlog, successfully? Any other more advanced prioritization frameworks you recommend? Do you use story points or hours? Yes, look, yeah, to be honest, I haven't done the Scrum part, at least me. That would be nice if today we had some member from our team, and especially the younger ones that really work on now on Scrum projects. There was, to my experience, at least on the Scrum ML cases that we have taken, there was no specific practice on that. It was always a matter of how specific the story points could be, and not having tickets going back and forth, and it was more of a culture thing on how things went. No, I don't have any specific Scrum advice right now on that. Next time we'll think of bringing also some team member that is, I have one in mind that would give you much more info on the Scrum part.
No, no about that, but just I can add something, because we work with Scrum ourselves as well in our team.
Mm-hmm.
And from a technology, we use Jira to write the stories. The story form, as far as the story format is concerned, so it's just like, of course, we have to define the goals of the story, right? To make sure that those who develop the part of software components or model components know exactly what the expectation is from an outcome perspective. And it's also easier to stay focused on what you're doing. So we write it actually in the Jira task itself. So this is what kind of expectation we have. We write also what kind of challenges we might face, and whatever, and leave it open for comments. So Jira allows for comments as well. Regarding prioritization, it's what we did when we started with one-on-one at one time. So a company I was working for. It's just prioritizing things in the backlog itself. So when you put it on the task list, it's just the ranking of tasks you set as a priority. And this helps as well. Sometimes for changes, I come from business and the tech side. So I have actually the double role. Sometimes I do prioritize differently and say, okay, guys, we see here problems. We need to put that ahead of the other things. Are you willing to do that? Are you commit to do that? And we discuss it in our daily morning meetings. So we have had 15 to 30 minutes meetings. And Nessis knows that because we work. And this is beautiful to start the day with, because you get everyone aligned. You get some feedback on what you have been doing on the task the day before, and this is also cool for people.
One important thing, thanks Stefan, also related to say for Jano question, just the technical detail, at least to all the cases we have worked until now on Scrum, it was always story points, not time. And there was this voting poker game. There are other flavors of that game, the beginning of its sprint and planning, and story points usually team ranks difficulty and of tasks, and it works. It's not that you can really adopt Scrum as it is directly to machine learning. The general framework. Can you hear me, or it's?
No, fine. We can hear you.
Great. I saw that. It's not that there are these considerations that have to do with the iterative workflow that we are talking, and that Scrum is very value driven, and machine learning that's a conflict of the models. Yes. So it seems team velocity is not something that, since it was mentioned in AI, focus on experimentation and learning, not delivering software as early as possible. Yes, it gets more complex than that, because usually they will expect you to go hand in hand in rhythms with the developer team, with the software engineering side. The agile team, that is an ML agile team, should have a special place for the ML and data science guys, that they have different synchronicities and different timings. That's what we have discussed many times in this presentation. I have a proposal sometimes, especially for those of you that are interested in Scrum. You know, it's the problem. There are some problems to fit machine learning in the classic, at least on the Scrum paradigm. It's because machine learning is not about functional requirements only. For Scrum, non-functional requirements were part of the definition to be done. That was the original inception. And the problem is that machine learning is evaluated mostly by its non-functional requirements that have to do with accuracy. It's not about only returning results, which is functional. So the problem with machine learning being on an agile cycle, working, especially not agile in general, Scrum, is that it's more on the definition of done. That's a little confusion there on how to define things. For all of you, any proposed things still need new development frameworks, new development workflows. We now try to adopt strictly software development, but machine learning and AI needs new development workflows too. First, that's any other question? Thanks, Savas. I can see. Thank you.
Yeah, as you've probably seen in the chat, I posted the link to Aneste's LinkedIn profile in case you want to connect. Yeah, no, I just saw your request. I confirmed it on LinkedIn. My network. So happy to connect. I think given the time, you just find time, and I think it's very late on your side, so it's near to 9 o'clock your time, Aneste, right, in Greek. I would say thank you again for just spending so much time and sharing your insights. It's always really a pleasure to listen to what you have to tell us. And I like the structure, so it's very helpful to walk through and say, okay, what can I learn? What did I miss in my journey when I do the work? So it's very helpful, very insightful. Thanks again, everyone who joined this evening. Thanks again, and I hope to see you next time again. We have a next episode next week, so just check if you have not signed up for it yet. It was a pleasure to have you all on board. I would say thank you and good night or good day, whatever time it is on your side, and hope to see you again. Say bye.
Best wishes from me too, and for happy projects. Happy projects I'm wishing. Yes, I will share the slides. Thanks, Stefan. Good night.
Thank you. Stay for a second. Thank you. Bye.